Yeah, you can start. We can start. We can start.
Okay, okay.
Okay. So once again, I welcome all the participants to the eighth session of this 5-day online entrepreneurship development program on design software for product development. We are once again privileged to have amongst us Mr. Dhruv Heron from Tool Room and Training Center, Guwahati. So without further delay, I request Dhruv to kindly start off the session.
Okay, okay, okay. So good afternoon, everyone. So today I'll continue from the block portion of the sketching. Okay, so yesterday I was discussing about the blocks. So what are blocks and where I can use it. Okay, so I have shown it by using some examples. I created some mechanism and converted those mechanism into block. So yesterday someone has asked me about can I make the whole sketch into block and convert into mechanism. uh, I think for that only there is only one case, so where you can convert all the sketches to block and still you can run it as a mechanism. So so a circle with a line from the center to the circumference. So if I try to make block and if I try to rotate it, okay, let me snap this into the origin. Okay, now if I rotate it, okay, so it will rotate now. Okay, so other than this, there is no case where you can do it. Only for this case, you can make the whole drawing as a block and try it as a mechanism. Okay, now if I try something other than this, let's say if I want to edit this, so what I'll do, I'll just right click over here, edit the block, and I'll try to add another more line over here. Okay, so now I'll go back. So if I try to rotate it, now you can see the line also rotate, right? Now if I fixed it, say, okay, so if I try to bend this line about this point, so it's not possible. You can see here, so it's not possible. So the only case is that a circle with a line is possible. Other than that, we have to create a separate block and we have to import into a solid box, then we have to combine it. Okay, so I'll move on to next case of block. Okay, okay, so I'll try to create this mechanism. So I have already completed a drawing and convert it into block. So what I'll do, I'll just import this block into the solid box. Okay, so now I need to create I'll just create one part over here. Okay, so 500 over here. I'll take 250 250 over here, 600, and just like 300 over here. Okay, so this will be my base. So you can see here, this is the crank base. Okay, now so for next I will include some point over here. Okay, so one point over here, another point over here, and I'll try to give dimension to this point. So I'll take this as 200 and another from this point to, from this line to this point as 150. Okay, another dimension for this point. So for horizontal dimension I'll give 160 and the vertical dimension from here, from to this line, and give us 220. Okay. So now I'll convert into block. So for this, either you can type here block, or you can go to insert, or no, sorry, I think it was in the, just search for a block. Okay. Okay, so you have to go to view, then you have to move to block. Okay, so you can go by this, or you can just click on the make block option. Now select the drawing and convert it to block. So after converting, so what you have to do, you have to rebuild the block, rebuild. So here is the option for rebuild, or you can just type the shortcut Control P. Okay, now after that, now I have created the crank base, and the rest of the drawing are already created. Okay, so this is the upper arm. Now I'll import the upper arm block into the SolidWorks. So for this, I'll go to insert block, and okay, so insert block, I think that's sorry. So after rebuilding, so what you have to do, again you have to go to sketch. Okay, just edit sketch. Now insert block. Okay, from browse, I'll go to the location where I've saved. So, okay, so here is the upper arm. Okay, so now this is the upper arm I have imported. Next, okay, I think there is two upper arm. I need to delete one. Yeah, just press Ctrl it to make these plain normal to the screen. Okay, so this will be your crank base. I'll just rename it over here. Just go to property and type the name as crankbase, and okay. Next, you can save this block by right clicking on the block and save as block. Okay, so next, again over here you can see upper, this is the crank base. Okay, so next I'll import another part for this mechanism. And here I'll import the central arm. Okay, so now you can see this drawing. Okay, so it's very scaled down. You can scale it by 6. Scale it by 6. Okay, I'll place it over here. Next, what I'll do, I'll snap this point to this point. So just click on the curve so you can see the center, and okay, so this is not a point. I need this point. Okay, click over here, and I'll place it over here. Just drag and drop on the onto the point. Yes, again, click on this point and drag it over here. Okay, now you can check the mechanism. Yeah, it's working. Next, I'll import the cylinder and the piston. Okay, so here we have the cylinder. Okay, cylinder, and now we have 6, right? Okay, so what I'll do, I'll import the cylinder and the piston, and I'll combine these two block as a single block. Again, I'll import the piston. Okay, here is the piston, and I'll scale it by 6. Okay, I'll place it over here. Next, so I need to align it, so I'll just click over here and I'll click on this reference line. Okay, so just hold control and select both of this both reference line. Now use collinear to align the cylinder and piston. Okay, next, so we need two cylinder piston arrangement, one over here and another over here. Okay, so either you can go to block and try it, insert block and try it once more again, or you can make these two block as a single block, and I'll try to import this full assembly over here. So what I'll do, I'll select the piston and the cylinder over here, right click over here and select make block. Okay, so now it has been converted in block. Okay, next, in the insert block, so you can see block tree, which is this arrangement. Okay, I'll place it over here. Okay, the only reason to make this as a block, just to bring the arrangement at the same time. Okay, okay, so now I just want to see the motion of the piston and cylinder. Okay, so if I try to do this, so it's not happening, right? Yeah, it's not happening. So this is because due to this. Okay, so because of the block, so we try to include two block in one block. Because of this reason, so this motion is restricted now. So what you have to do, so after importing, so I'll try to break the block once again. So I'll remove the edit block. I'll select block and right click over here. I'll explode the block. Again, for this, I need to explode once again. Explode the block. Next. Before exploding, wait. Okay, so before exploding, so do one thing. So I'll scale it 1.4. Yeah. Okay. Scale it by 1.4. Okay. Now I'll try to explode the block. Okay. Now, so now what I'll do, I'll take the center and I'll drop it over here, and the center of this point over here. Next, for this, I'll take this point and I'll drop over here, and another point I'll drag it over here. Okay, so now it has been completed, and what you have to do after completing, just click on rebuild. Okay, click on rebuild and edit the sketch. Now try the movement. Okay, so in this way you can check mechanism in SolidWorks. Okay, so only in one case where you can select all the entities and convert it to block, and you can try it as mechanism is the first case one, the circle with a line. Okay, in that case it is possible. Other than that, so it's not possible to try as a mechanism. Okay, so this was the last one of the sketching module. Now I'll move on to the part modeling. Okay. Okay, so in part modeling, so we'll be creating some virtual prototype using some features available in the part module. Okay, so it is the first building block of any large scale design, and later you can use this part to assemble the product in the assembly module. Okay, so so in the part, so we have volume addition, which is boss. Then we can cut the material, volume removal. Then we have features like fillet, chamfer, shell. That means to hollow the internal part. And we have rib. Okay, and many more are there inside SolidWorks. Okay, so now I'll start with a new page. So click on new, click on part design. Okay, and I'll change the unit to millimeter. Okay, so I'll start with boss. So where you have to add the volume onto the sketch. So before that, so you need a sketch. You need a sketch. Okay. So I'll use a rectangle, center rectangle. Okay. So now I'll use some fillet over here. Sketch fillet of 10. So I'll just select the point over here. Instead of selecting line, you can select the corner to apply fillet. Press OK and exit. Okay, you can also give dimension. So from this point to this point, we have 130, right? I'll make it as 140. And from this point to this point, I'll make this 70. Okay. So after completing the sketch, just exit. Okay. Now the sketch is ready. You need to add material over it. So for this, I'll go to the feature tab. So over here, you can see the part features available. So starting with extrude boss. Okay. So what it does, it tries to add material in a direction normal to this profile. So select the extrude boss, select on the sketch. Okay. In case if you have problem selecting it, in case if it doesn't occur, or if it doesn't select, so just go to select contour and select the inner surface. This way also you can select the sketch. Next, you need to add height. So right now you have 32. Now you have 32. So either you can change the dragger over here, or you can enter the value over here. Okay, so I'll give a thickness of 30. Okay, and there are various method over here. Okay, so you can see blind up to vertex. That means up to which point you want the material, so you can extend it. Next, we have another direction. So this is the direction one, and if you want material to go in this way, so you can select direction two. Okay, you can select in direction two, and next comes the draft, which applies taper on the. You can apply taper on the faces. So if I select draft, so what it does, uh, it tapers the face from a from a parting face. Let's say I give a draft of 3° inward. Okay, so they're taking the angle from the normal face. And on the second direction, I'll take a draft of 2. Okay, just click OK. So this is how you can create solid. Okay, so now if you want to edit this part, so what you have to do, you have to come over to the feature tree, and over here you can see the history. Okay, so right now I have used the extrude boss, so which will be located in the feature tree. So in order to edit this, just right click over the boss extrude and click on edit features. Okay, now here you can change the parameter over here. Okay, okay, you can change it over here. So I think one features is disabled now. There are 15 features at the beginning, but now after completing it, if I go to edit, so it won't be available over here. What I'll do, I'll just delete this. I'll just undo it. Okay, if I go to extrude boss, I'll click the sketch. Okay, so there is an option for 10 features. Okay, which will allow to hollow the part and leaving some thickness on the boundary. Okay, so here you can see here. So let us give a thickness of 3. Okay, so here you can see one direction, mid plane, 2 direction. Okay, so that means the distribution of the material from the sketch. So it is one direction, which is in outward direction now. You can select mid plane. Okay, so on the both side of the sketch, and on 2 directional, that means you can enter value in both direction independently. I'll just select one direction, and here you have cap and to close the box. Okay, so what we'll do, they'll try to keep only the, they will make only the inner portion hollow, and the rest they will close it using cap. So if I press OK, so you won't be able to see it, but if I use the cross sectional view over here, okay, so here you can see it's hollow from inside. Okay, so here you can change the plane. So this was the front plane, this is the top plane. So you can move the tride. This is called tride. Okay, so using the tride, you can translate the plane or rotate the plane. Okay, so you can see here it's hollow from inside. This was the extrude option. Next, similarly, for cut, we have extrude cut. In case if you need a hole over here or any cut, so before that you need to create a profile on the surface. Okay, so for creating a profile, I'll go to sketch, I'll select the surface. So I need a cut over here. I'll select the surface, click on the sketch. Now press Ctrl+8 to have the normal view. Now I'll use a rectangular cut, or I'll use the center rectangle. Place it over here. Okay, so now I want a rectangular cut over here, exit the sketch, and I move on to extrude cut. Okay, so using the slide, you can change it, or so over here there are various methods to extend the material or material cut. So in blind, so you need to enter value up to how much distance you have to cut, and there is an option called up to next. Okay, so the cut will happen up to the next boundary. So we all know that on this part I have created a hollow inside, right? So there is a surface next to it, so the cut will extend up to the next surface. If I click OK, so you can see here this cut have extended up to the next surface. Or you can also do up to surface. Okay, so I want this cut to extend up to this surface. Okay, so what I'll do, I'll just create edit. I'll just go to edit. I'll change it to up to surface. Now I'll extend up to the surface. So you need to select the surface. Okay, so and the cut will extend up to the surface. Just press OK. Now you can see the cut has extended up to this surface. In a similar fashion, so for extrude boss also you can extend the material in same way up to next. Okay, I'll show you another example of I'll show you another example of up to surface. Okay, so where you can use it. So now what I'll do, I'll take a plane. I'll take this as a reference plane. From here I'll take an drawing plane at a distance of 40 mm. So what I'll do, I'll go to reference geometry. From here I'll select plane. Okay, so I need a drawing plane under this tree plane. So I'll select the plane, and the first reference will be this plane. Okay, now from this plane I'll take a drawing plane at a distance of 40 mm. Okay, now I'll take the normal view of this plane. I'll go to sketch. I'll try to create a sketch of it. Okay, now I'll select the extrude boss, and let me reverse the direction. Okay, so I want this to extend up to here, right? So if I go blind, so I don't know up to how much I have to extend. Either you can go manually, but I don't know how much I have to extend. So if I select 40, so it will extend up to this face, right? So either you can go up to next, or you can select up to surface. So you need to select the surface. Okay, you can go up to next. So in this way you can use it. And for up to surface, I think you'll need a curved surface. Okay, so there shouldn't be any plane surface. So I'll get another example over here. Where is trim entities? I'll trim this part, and I'll use offset entities. Reverse it. Okay, extend, sorry, I need to extend this. I'll extend this arc and I'll remove this line. Okay. Now I will I'll extend it up to here. So select the surface up to vertex. Okay, so you can give height in this way also, up to vertex. Next, yeah, so I'll edit this plane. Oh, okay, I'll try to draw another sketch on this plane. So on the same plane, I'll draw another rectangle. Okay, and what I'll do, I'll reverse the direction. Now I'll use up to surface. So in surface, I'll select this surface. Okay, so upon selecting, so material will extend up to this surface. Okay, in this way you can use the extrude boss. Okay, so next comes the revolve base. So using revolve base, you can create a volume that rotate about its axis. Okay, so by using this you can create a cylinder. Okay, cylinder, or you can create any solid which resemble like this. Okay, so for this you will need a cross section of that solid. So I'll use the right plane over here. I'll select sketch. Okay, so now first I'll draw the axis first. Next I'll draw the cross section of that model. Okay, so this is the this is the cross section I've created for the revolve features. Now what I'll do, I'll select the revolve piece and I'll click on the sketch. So SolidWorks will automatically detect the axis. Okay, so in this way you can create the revolve features. So I've created only the right side of the cross section. Okay, so you have to just draw the any side of the cross section, either on the right side or left side. Okay, so another option, I think. Okay, give direction to select the contours now. Okay, so for the cut portion, they have revolve cut. Okay, just like the revolve piece where you have added volume, here we have revolve cut. So using the revolve feature, you can cut the material from here. So what I'll do, I'll select the same plane. Okay, right plane, and I'll use normal view. Now what I'll do, I'll create a groove on this cylindrical body. So what I'll do, I'll select okay, I'll select a circle on here. Okay, next I'll need an axis. So for this I'll use center line. Okay, I'll create another group over here. So I'll use circle. Okay, now I'll move on to revolve curve, and SolidWorks will automatically detect the center line or axis line. and upon selecting, you can see they've shown the preview. In this way, they will remove the material from the cylinder part. Click on OK. Okay. So this was the revolve cut. So using revolve features, you can cut the material away. Next, we'll move on to swept pause. Swept pause. So using swept pause, you can create any pipeline structure or duct. So any solid that is following on a closed part or along the open part. So I'll take the top plane. So what I'll do, I'll create a path. Okay. I'll add some fillet over here. Let's fillet of 20. One over here, another over here. Press OK. So I've created the part. Now what I need the profile or the cross section. Okay, I need the profile. I want any of the I want the profile to follow on this part. Now what I'll do, I'll create a normal plane. Okay, and the plane should be normal to this curve. What I'll do, again I'll go to reference geometry. I'll click on plane. So first on in first reference, what I'll do, I'll select the line, and in second reference, I'll select the point. Okay, and so in this way you can create a plane which is normal to the line or any curve. Now click on the plane, press Ctrl 8, again press Ctrl 8 to view from this side. Go to sketch, and what I'll do, I'll create a circular profile. I'll just rotate it. Okay, so make sure that the radius of the circle should not exceed the radius of the fillet, right? So I have used a radius of 20, so the circle radius should be less than 20. I'll use a radius of 6. Okay, next exit the sketch, and I'll move on to swept pause, right? So the profile is automatically selected, or if it is not selected, then you can select the profile first, then the part. Okay, this way you can create sweep profile. Okay, so for this we need a profile and a part. Okay, so we have other option for this, like guide curve. Okay, we have guide curve, then we have tangency option. Okay, so this is advanced option. Okay, and if you want this pipe to, if you want to follow this pipe, then you can use the thin features over here, and you can add the thickness in the pipe. Just click OK. Okay, is my voice audible? Hello? Hello? Hello?
Yes, sir.
Okay, okay. Okay, so next. Okay, in a similar way, you can do the swept cut. Okay, so for swept cut, okay, so I'll show you over here. So what I'll do, I'll select this face and I'll draw a sketch. Okay, so starting from here to this point. Okay, I'll use a fillet over here, 20. Okay, the part is created. Now I'll select, I won't select any plane, or I won't create any plane. I have this plane, so I'll select this plane and I'll draw the circle over here. So next, I'll move on to swipe cut. So it is selected, then I'll select this curve. Okay, yeah. So there's a problem over here. I should have selected this plane. So I have to create another plane over here. Click plane, select the line first and the point, end point. Now I'll select this plane and go to sketch and create a circle over here of radius 6. Okay, now I'll click on swipe cut. Okay, the profile is selected. Next I'll use path. Wait a minute, maybe due to this, I think so. Okay, so I have to remove the coincident. So in order to remove the relation, so I'm clicking on this point and automatically a property manager appears over on the left side. Just click on the existing relation, coincident, and delete it. Okay, so now you can extend it up to here. Okay, exit it. Now I'll use swipe cut, select the profile, then the path. Okay, then press OK. So in this way you can use swipe cut. You just have to remember that you need a profile and either you can use an open path or closed path. Okay, next comes the loft and boss. Okay, so for loft and boss, I'll use this example. Okay, I'll create a hammer using loft and boss. Okay, so for loft and boss, so what is loft and boss? So what happens till now? So in extrude, the profile, sorry. So in extrude, if you see the base profile, here you can see rectangle. On the top profile, from top profile also we can see a rectangle, right? And in sweep, so if you see from this, if you take any plane, you will see a circular cross section, right? In loft, so what you can do, we can use two different profile and we can create a solid using these two or more profile, and we can create a solid using loft and boss. Okay, so if you see the hammer, so you can see if we move in this direction, so there are various profile over here. We have circle, and here we have rectangle, again here we have rectangle, right? So using various profile you can create a solid using loft. Now I'll use another face. Okay, I'll show you it over here. Or I'll just hide it. I'll just use some paste. Okay, I'll use the front plane. Okay, so for loft you need different profile at different distance, right? So first what I'll do, I'll take 4 planes. Okay, I'll go to reference geometry. I'll select plane. So this will be my reference plane. From this plane, I'll create another plane at a distance of 25. Okay, and I needed a plane of total 5 planes, including the front plane. Okay, so this is 25. Another plane I need. So for this, I'll create number of plane 2. Okay, so in this way you can create multiple plane. Okay, then using this plane as a reference, I'll create another plane at a distance of 40, and again using this plane as a reference, so I'll create another plane at a distance of 200. Right. Okay, next I'll select the front plane and press Ctrl 8 to have the normal view. I'll go to sketch. Okay, let me see where is the normal plane. Okay, this is the front plane. Okay, or you can just hide it. Okay, so you can select all at a time by clicking on the plane 1 and press shift and click on the plane 4, then hide. Okay, here is the plane. So the okay, so I think I've done a mistake. Okay, so this plane. Okay, so the reference shouldn't be from here. It should be from the front plane in opposite direction. Okay, so now it's okay. Okay, so rest and hide the plane and use front plane and go to sketch. Okay, so first I'll draw a circular profile. Sorry, circular. I'll draw a rectangular profile. Okay, so the sides are 60. Okay, so after this, I'll turn on the next plane, which is at distance of 25. Just Control 8, go to sketch, and use a circle. I'll take a circle of 50. Okay. Next, I'll turn on the second plane. Okay. Control 8. Use sketch. Okay. For this, I won't use any radius, but I'll take this diagonal distance as the radius from center to this point. Okay, another plane at a distance of 40, right? So what I'll do, I'll create the same circle over here. So what I'll do, I'll click on this circle from the edit menu bar. I'll select copy. Now I'll select this plane, and over here I'll paste it. Okay, so in this way you can copy and paste the sketch on different plane. Now this is the profile. Now I'll go to loft. Okay, so in loft I'll select the profile one by one. First profile, second profile, third profile. This is the fourth profile. Okay, in case if your selection is not synchronized, okay, let's say if you've selected first this and this, then you have selected the rectangle third and you have selected this as fourth. Okay, what you can do, you can use this move up move down button to change the orientation. Okay, so now sketch tool, sketch. Okay, go to note. Okay, if this doesn't happen, then just erase it and try once more again. Okay, so now it's completed. Just press OK. Okay, so in loft you can use profile. Along with profile you can use guide. Okay, guide to guide the material or how the material should flow. Press OK. Okay, so now I'll turn off the plane. Hide, and hide. Next, so another plane which is at 200 mm from here. So here I use this plane. I take the normal view. I use center rectangle. Okay, so whose dimension is 75 and the thickness is 5. Okay, next, so what I'll do again, I'll use loft and boss. Okay, so I need to select the edges, or what you can do, just select on the face and next select on the sketch. Okay, so now there is no preview of that material because it is not synchronized properly. You can see the node, one node over here, another node over here. What you have to do, just drag it and bring it over here. Just align the node. Just press OK. That's it. So that is how you can create the ball peen hammer. Sorry, this hammer. So now you can see here is a band over here. Okay, to create this band, so you can use an option called, so which in feature called flex. So using flex, you can twist the band the material. So now I'll select the flex. Okay, so here you have option for this twisting, tapering, stretching. We have option for this. So what I'll do, I'll select the body. Okay. Okay, so here you can see the trial. Okay, so if I try to bend it now, okay, so the whole body will try to bend about this point. So this will be a center point, and this is the trim plane 2, this is the trim plane 1. Okay, so they'll try to bend from this point. And make it as 0. Yeah. So next, what I'll do, I want this to be same, but only this side to be bending. So next, I select the trim plane tool. This is the trim plane tool. I want this plane to be over here. Okay, on this face. So what I'll do, I'll select this point. Okay, and I want this right over here. Okay, so the bending take place about this point. Okay, so rotation, so the rotation take place about x-axis. Okay, this is the x-axis, so rotation take place about this axis. So now I'll click on the triad, right click and align to. Okay, so I want the z-axis to align with right plane. Okay, again click on the triad center, right click, just left click once, then right click, then move the triad to triad plane 2. Okay, now the triad has moved to this plane. Next, select the trim plane 1. So either you can select the vertex. Okay, you can select the vertex and try to bend it now. Okay, I'll bend it by 30 degree. Okay, so in this way you can create the flex. Okay, so there are other options for this. So here you can see bending, twisting. Okay, so I'll take it to 0. I'll change this vertex plane. Okay, now you can twist the material also. So if I select twist, you can twist the material. Next we have tapering. Okay, and next we have stretching. For tapering stretching, we need a rectangle bar. Okay, rectangle block. So here it's not possible. So I'll create another rectangle bar. Okay, I'll add volume over here. 10 mm. Yeah. Next, I'll go to insert features. I'll select flex. Click on the body. Okay, now you can see by changing angle, you can see the bending. Okay, so the plate is bending about this point. Okay. Now here's the option of twisting. Okay, next we have tapering. Okay, so here you can see the taper start from this stride point. Okay, so if you can change the stride point from here to here. Next we have stretching. Okay, in stretching you can stretch the line. Click on stretching, click on the body. So if you're on the stride point over here, so what you can do, click left click over here, right click and move to stride plane 1. Okay, now you can stretch it. Okay, we can stretch the bar. And in tapering, if you observe from the top view, you can shade the tapering. Okay, so these options are available in Flex. Okay, so I've shown you the loft button. There are various other methods to create loft structure. So here I have used only profiles. Okay, 3 to 4 profiles I've used. So in some loft you can use guide also. Guide. Okay, so I'll show you another one. So using guide, yeah, you can create a loft structure. So I'll use sketch. I'll use top button. Control 8. Okay. Okay, so here I'll use ellipse. Ellipse. I'll take it this as 40. Sorry. Dimension. Okay, I'll take this as 40 and I'll take this as 20. Okay. Next, I'll take another plane. Okay, so now I've used top plane. Okay. Now taking top plane as a reference, I'll create another plane at a distance of 30. Okay, this plane appears over here. Yeah, you can extend it up to here. Just use Control 8 and go to sketch. Okay, the center will be same. Now I'll create another ellipse. Okay, so I'll keep the distance over here as 50 and this distance as I'll keep it as 20. Okay, so 2 planes are created now and another plane. Okay, I'll take this plane as a reference. I'll create another plane at a distance of 20. Okay. Here I'll use a circle of diameter 20. Okay, so now okay, so I've created the profile. Now I'll create the guide curve. Okay, guide curve center length parameters. Okay, so to create guide curve, so what I'll do, I'll place a plane over here. Okay, so I'll use reference plane. Sorry, I won't use a reference plane. I'll select plane. I'll select 2 point, one over here, another over here, and another at here. Okay, create a vertical plane in this case. Now in this plane, I'll draw a curve using spline. Okay, I'll draw a curve. Okay, let me hide this. do this. Okay, not on this plane, on this plane. Okay. Control 8. So I'll use a spline starting from here, next here, and next here. Okay. Now what I'll do, I need to merge this point to this curve. Okay, so for this I'll use pierce. Okay, similarly over here, I'll use this point and this curve pierce. Next, I'll use this point and this curve pierce. Once it's completed, now I'll use the lock base. First, I'll select the profile. So I'll select the profile. Okay, and now I'll use the guide curve to guide the material. Okay, so you can see upon selecting the guide curve. Okay, so the material, you see the material alignment, right? So the material is following this guide curve. So if I remove it, you can see here. So upon adding the guide curve, you can see the difference. Okay, so using the guide curve, you can create loft. Okay, so next, so what I do now, I want to create a hollow body. So for this, I will use shell command. So I'll select shell and I'll click on this face. Okay, I'll click on this face and I'll use a thickness of 0.5 and then okay. So if I see the cross section, okay, yes, okay. So here you can see, right. Although the cut is not properly done, but you can use extrude cut. Okay, extrude cut and cut the remaining portion. Okay, so again I'll show you how to use the shell. Okay, so lock. I'll select the profile first. Next, the guide. Okay. So I'll turn off the sectional view and I'll use shell command. Okay. So I need the shell. I need shell to start from this face. Okay. I need the shell to start from this face, and I need a shell thickness of 0.5 mm, and then press OK. Okay. Okay. So this is how you can create a lock body. Okay. So where you have different profiles, and by adding those profiles, you can create a solid. Okay. Similarly, you can create a lofted cut. Okay. So we can create lofted cut. So for this, I'll use this body. I'll show it over here. So now I can say I can directly edit the solid height just by clicking on the surface and by dragging this pointer. Okay, you can directly edit over here. Next, so I'll use lofted cut. For lofted cut, I'll draw one sketch over here. Okay, I use a circle. Okay, I use the tracing line and exit the sketch another sketch over here. I use ellipse. So I'll just use this tracing line. Okay, so what you have to do, just bring the pointer over here and move the pointer toward the center, and also from this point. So, okay. So you can see this tracing line meet at a point. So click the pointer over here, and you can create ellipse. Okay. So you can add some guide curve. For now, I'll just use two profiles. Just select the lofted cut, click on the profile, and you need to arrange the node properly. Okay, and then just press OK. So now you can see here, if I use the sectional view and I use the right plane, right plane, and drag the cursor over here. Okay, now you can see the lofted cut. Okay, this is how you can use lofted cut. Okay, so the basic volume addition and volume removal command are done. Now comes the dressing features like fillet, chamfer, okay, or pattern, mirror. So first comes the fillet. Okay, so in the fillet, so just like in 2D, so we have to remove the sharp corner or sharp edges. So just select fillet, and here over fillet, you'll see different type of fillet. Okay, we have constant size fillet, then we have variable size fillet, next we have face fillet, and here we have full round fillet. Okay, so I'll use one example to show this. Then simple fillets. Okay. Okay. So here's an example. So here, what I'll show you the types of fillet and also a mirror option, how to mirror a part. So starting with fillet. Okay. So I'll start with face fillet. Okay. So using the face, you can create a fillet over here. So what I'll do, first face should be this. Okay. And second face, I'll select this. So here you can see the fillet. Okay. Fillet is created. Next, what I'll do, I'll select from fillet parameter, I'll select whole line. Okay, so now the type is symmetric. That means the distance from here and here is 10. I'll use whole line, and here in whole line, I'll select this line. Okay. So they'll show you the preview how fillet has been created. I'll just press OK. Okay, so this way you can use face fillet. Okay, so next we'll move on to constant size fillet. Okay, so in constant size fillet, they will apply constant fillet, means constant radius fillet onto the edge. So what I'll do, I'll just select the edge over here. I'll apply a constant size of 5. Okay, so it will maintain this radius along the edge. Remaining, okay, constant size, and then press OK. And here I'll include under fillet over here. radius 2. Okay, so in sketch, so what you have done is that in order to apply fillet, you need to select either the point where the two lines are meeting or the lines, adjacent lines. Okay, so this is how fillet are created. Now I've shown two types of fillet, constant and the face fillet. Now here we have variable size fillet. Okay, so in variable size fillet, uh, you can vary the fillet thickness. Okay, so I've selected the variable size fillet. Just remove the tangent propagation. Okay, not variable. Asymmetric. One. Hello.
There are some background noises. Can you just minimize them?
Hello. Is there any problem?
Yeah, there are few background noises.
Uh-huh.
There are few background noises. Can you please minimize them?
Okay, okay. So I'll try once more. Select constant size and select the edges. Okay, now it appeared. Okay, just press OK. Okay, so here you can change the type of fillet parameters. So I've selected the asymmetric one. Okay, and okay, so I've shown three types of fillet. Now next is the variable fillet. Okay, so in the variable fillet, you can vary the size of the fillet along the edges. So I'll select this edge, then this, and this. Okay, so now I'll use symmetric. Okay, symmetric. So there are multiple edges over here. Okay, so I'll keep, I'll select all the edges and I'll give us 1.5, and here except for the first node and the last node, that is okay, this node and this node. Okay, so v2 and v5, I'll maintain a fillet radius of 1. Okay, so in this way you can vary the fillet size. Okay, just you need to select the edge, sorry, vertices, and you need to set the radius over there. Okay, and press OK. Okay, so this is how you can apply fillet. Now I'll use mirror. Okay, so to mirror this part, I'll create a mirror part of this body. So I'll select mirror. Next, for mirror face, I'll use the right plane. This is the right plane, and here features the mirror. I'll select, sorry, I'll use body to mirror. Okay, this is the body to mirror, and press OK. Okay, so now you can see the body have been merged. So if you see from this side, you can see the surface. You can see the surface, it's not smooth. Okay, there are some edges over here. What I'll do, I'll try to smooth it using fillet. So I'll use constant size and I'll select the edges. Here I'll use a fillet radius of 5. Fillet radius of 5. Okay. Okay, so this is how you can use fillet in SolidWorks. Okay, so another feature is chamfer. So just like your in 2D sketches, so there they have removed the corner with a bevel edge. Okay, so here they will cut the corner and replace with a bevel face. So I'll show it over here. I'll use chamfer. So in chamfer you have 2 methods. Now they have added 3 more. Earlier it was 2 methods. Okay, so we have distance and angle, and here distance and distance. Okay, now they have added vertex, then we have face, then offset face. Okay, so in angle and distance you have to mention the angle and distance. Okay, so I'll select 10 mm and angle is 45. So I'll select this edge. Okay, so they will show you the preview. Just remove this. Okay, so they will show you the preview of the chamfer. Okay, so here the distance is 10 and angle is 45. That means from this point to this point the distance is 10, and since they have maintained angle 45, that's so you can say that the distance from this point to here also is 10, right? This is the angle and distance method. Next we have distance and distance method. So we have to mention the two distance. So here we have symmetric. That means if I press symmetric, they will take same distance from this corner. Next we have asymmetric. You can give different distances. Here I have 10. I'll apply 20 and press OK. Okay, so what they did is they removed the sharp corner and replaced it by bevel face. Okay, so fillet and chamfer. So these are the dressing features. Next, I've shown you the mirror. So next comes the rib. Okay, so this is used as this can be used as a support in the part body. So I'll show you an example. Okay, so I'll use default pose. I'll select this axis. Okay. Okay. Now, so I'll use shell to hollow the part. Okay, so I use to. Okay. So next, now I have to apply some rib over here. Okay, so some supports. So what I'll do, I'll use this plane. Okay, so I'll copy this plane. I'll place it over here somewhere here. Okay, now I'll draw the rib profile of here. I'll complete a rib on this plane. So I'll go to sketch and I'll select this plane. Press Ctrl 8. Next, so I need the boundary of this. Okay, so I need a boundary of this curve. So for this, I'll use intersection curve. I'll select the body, or you can use the surface and press OK. Okay, so you can see boundary has been created where this plane intersect. Now I'll use offset. So the current thickness you can see here. Let me check the thickness. So what was the thickness? Okay, it was 2. Now I'll use an offset of 2 mm. Okay. Okay, so this is the boundary. So just remove the outer boundary now, and I'll create a line from here. From here till here. Okay, so I'll create a rib over here, and I'll include another one over here. Okay. Now I'll just remove the circle, exit the sketch, go to rib, and select the line. Okay. Now they will ask the direction. So in which direction you want the rib? Okay, so either in this direction or in downward direction. So just select the direction. So now you can see the arrow which is pointing downward. That means the rib material go in downward direction. So click over here and just press OK. Okay, sorry. I think I've done a mistake over here. So what I'll do, I won't delete this circle. What I'll do, I'll convert it into construction line. So just select a circle. So a menu appear over here. So just click on construction geometry. Okay, so by doing so, it will convert the solid circle to construction geometry. Next, I will delete this line. What I'll do, I'll try to input this in the next line. Select sketch, plane it. Next, I'll select the line. Okay, so what I'll do, I'll use convert entities. I'll select this reference circle and convert it into sketch. Okay, so this sketch will appear on this new sketch. not the other one. Now also I'll convert this into construction geometry. Now I'll start the line from here till here. Okay, so here we have two lines on two separate sketches. Okay, next we'll move on to rip command. I'll select the line. So here you can see, so they have shown me the direction. If I select this, so you can see the arrow direction. So the rip material will follow in this direction. Okay, let us see. Press OK. Select the button which will create. Okay, change the direction. Okay, sorry. I need to select the body. Yeah. Okay, so maybe this may be due to the shell command. Okay, so what I'll do, I'll use offset entities. Let's reverse it and press OK. Okay, so I'll just add the center line. Okay, now I'll use the rework command. Okay, next. Okay, so where is the plane? Yeah. So I need another plane. So from where the rip will start. Okay, so what I'll do, I'll just take a reference plane from this plane. So I'll press the control. I'll put the pointer over here. So you can see a move icon. Just drag it to a distance of let's say 35. Okay. Now on this plane, I'll draw the report. So for this, first I have to use intersection curve to bring the curve out. Next, I'll use offset onto this, reverse it by 2. delete the outer circle and convert the inner circle to construction. Draw a line from here to here, exit, and try the with command and change the direction. I'll use the body, press OK. Okay, now you can see here rib is created. Okay, this acts as a support in mechanical parts. So if we use the sectional view, okay, so you can see here. So this is the rib. Right. So you can use them as a guide in the mechanical parts. So this is one way. Or you can also add rib in this direction also. So I want rib to start from here to here. So what I'll do, I'll use the front plane. I'll use front plane. I'll go to sketch. Just control it. Okay. So what I'll do, I'll change the view of the drawing of this model. So right now it's in shaded with edges. I'll change it to hidden line. Sorry, hidden line. Now I want rib to start from here and end it up to, let's say I want to end it up to here. Okay, again I'll change the view to shaded with edges. Now I'll use the rib command, select rib, just see the direction. Okay, you need to flip the material inside and select the body and press OK. Okay, so this also you can add rib to the 3D part. Okay, so next okay, so next comes the pattern. So here in pattern we have different types of patterns. So out of this, linear pattern, circular pattern, and curve driven and sketch driven pattern. These are important. These four patterns are important. So for this, okay, I'll start a new piece. Okay, under sketch, I'll select the top plane. Okay, I'll create a plane and I'll show you how the linear driven pattern can be used. So before that, I'll use dimension. Oh, sorry, it shouldn't be repeat. We shouldn't repeat the dimension over here. It's fully constrained. Now I'll use the extrude boss to add some volume. Okay. Now to apply linear driven pattern, so either you can create a solid over here, okay, or you can cut. I'll select this face. I'll use sketch. What I'll do, I'll just use slot to cut out a material. I use extrude cut. Press OK and press Ctrl. Okay. So what I want to do, I want a multiple copy of this slot in this direction and also in this direction. So what I'll do, I'll use linear pattern. Okay. So in linear pattern, so select linear pattern. From here, you need to select the direction. Okay, so So in direction, you need to select the edges. Okay, so you need to give direction. So I want this part numbers. Sorry. Okay. I want a copy of this part to follow in this direction. So I'll select the direction over here. Next, so how many copy you want? I'll select 4 copies, and the distance between 2 copies, I'll keep it as 20. And in features and faces, I'll select extrude cut. Okay, and I want another copy in this direction, so I'll just select the direction, click on direction 2 and select this edge. Okay, and here I'll change the distance between 2 copies. It's 30 and numbers of item to be 5. Okay, so I'll keep it as straight and I'll just flip the direction in this direction. Yeah. Next, click on geometry pattern and press OK. Okay, so in this way you can use linear pattern. Okay, so next comes the circular pattern. Okay, so for circular pattern, you either need a circular edge or an axis. Okay, so for circular pattern, here, I'll use the circular pattern in here. So, okay, I'll use the right plane, Control 8. I'll use a center slot. Okay. Next, I'll use extrude cut to cut the material. Next, what I'll do. So now what I'll do, I'll use a temporary axis over here. So for this, I'll select the axis and I'll select the circular edge. Or circular edge, or you can select the face. Okay, so for one line axis, okay, so it's not possible to create. So what I'll do, I'll use another example. Okay, so for now, I've made the cut. So I'll go to circular pattern. Okay, so in direction, so what I'll do, so I wasn't able to create the axis, but what I'll do, I'll select the circular edge. Okay, I'll select the circular edge, then I'll use equal spacing and I'll give a numbers of item 3. Okay, and so in features and faces, I go to design tree and select the cut extrude, then press OK. So in this way, you can use circular pattern. Okay, so I'll use another example to show this. pattern, right? So where's the pattern? Yeah, pattern. Yeah. Okay, so what I'll do, I'll use the linear pattern and circular pattern in this example. So I'll use the front plane. Okay, I'll use the front plane, make it visible. I use the sketch, press Ctrl 8 to have the normal view. Now I'll use slot, center point slot, and do it over here. Take this distance as 10, and from here to here is 5. Or you can take this, or you can apply constraint, symmetric constraint. I use vertical. Okay. So now from here to here, I use a distance of 60, and the radius I'll take as 5. Here, I'll take the center to center distance as 10. Sorry, it should be 2.5. 2.5. Okay. Press exit, and here click on extrude cut, and you can select up to next. Okay, select up to next. It will extend up to this surface. Press OK. Okay, now I need to create an axis. Okay, so you can create axis by selecting, go to reference geometry, select axis, click on the cylindrical surface. In this way, you can create temporary axis. So in this example, so they've already created the temporary axis. So you have to go to hide and show, and just turn on the view temporary axis. Okay, so here you can see here. Okay, next, go to linear pattern, then okay. Next, select linear pattern. Click on the cut extrude. Sorry, select the direction. So for direction, you can either click on dimension. Okay, so which is not visible right now. Okay. Just select the pattern first because I was looking for the dimension. Okay, click on the pattern first, then in direction. So here either you can create select on the axis or you can click on the dimension. Okay, so click on the linear dimension, and here I'll give a distance of 10 and change the direction. Okay, click on the direction and press OK. Okay, so in this way you can use linear pattern. Now I'll use circular pattern and hide this. Now go to circular pattern. So I'll use the pattern first. Okay, so let me select the axis. I select the axis, then I'll use equal spacing 360° and numbers of item 3. Okay, so upon clicking the axis you can see, okay, you can see the cut has been distributed in circular pattern. Okay, now so what you can do, now you can add equation. Okay, so you can add equation and you can increase the numbers of pattern just by editing in the column. So here to add equation, so I'll just type equation, yeah. So I'll click on sketch equation view. Sorry. Okay, I'll click on here equation view, click on add equation. So in equation, okay, the equation part I'll show you tomorrow. I think there is some option not available here. You need to turn on the option. Okay, so I'll keep it here over here. Next, we'll move on to wrap command. Okay, so using wrap, you can imprint or emboss some drawing over the surface. Okay, so what you can do, so I'll use the front plane. Using this front plane as a reference, I'll create another plane over here, and here I'll create a drawing, simple, or I'll use a text. Okay, I'll use a text, and I'll select the curve, and I'll add solid works. Okay, I did the font over here. Okay, so after this just press OK. So what I'll do next, I'll hide it over here. Okay, so now I use wrap option. So select wrap. Now there are different wrap type. So here you can emboss material, then you can deboss. That means you have to remove material, or you can add material. Next week you can scribe it. So what I'll do, I'll just depose the material. So select this sketch, select this surface. Okay. Right. Select the sketch, select the surface. I'll use the brush and pull direction. So I want to remove the material by using this as a tool body. Okay, so just press OK. Open contours. Okay, so here you can see. So in this way you can wrap it. You can use wrap and remove material using different type of tool body. So here our tool body was this text. Okay, so either you can imprint or deboss, or just you can scribble on the surface. You can use emboss, so they will add material over it. Okay. Okay, so another one is we have scribble. So what they'll do, they won't add any material or remove material. They'll just imprint the text on the surface. Okay. So today I think the time is up. Tomorrow I'll continue again from here. So tomorrow I'll show you how to use the equation in this pattern. And remaining, I think 2-3 commands are left. So we have whole wizard, and over here we have fastening features. So I will show you tomorrow before starting assembly and surface design. Okay, so hello.
Thank you, sir. Thank you, sir,
Okay.
for the session. And if participants have any doubt, they can ask now.
Thank you, Dhruvajeet.
Okay.
Once again for such a
Thank
wonderful
you.
session.
So it's lot to take now in one day. Okay,
Yes,
so
yes.
it's a very used software. So you can't complete in 2 hours. Still try to apply it. Okay.
Right. The more they will practice, they will be able to grasp.
Yeah. You need practice. Means they need practice to become to have some idea on SolidWorks.
Yeah. Yeah, Dhruvajeet, there is one request.
Hello.
Yeah, Dhruvajeet, there is
Yeah.
one request.
Hello.
Yeah, can you hear me? Yeah, can you hear me?
Yeah. Sure.
Yeah, so your the last session was scheduled from 2 to 4 tomorrow.
Yeah.
So
No.
will it be possible? So will it be possible for you to take from say 11 to 1?
11 to 1.
Yeah.
Yeah. I can do it now.
Okay, so we have a 1 hour session from 10 to 11 by some
Mm-hmm.
other faculty member. Then after that, maybe 11:15 or something
Okay,
like
okay.
that.
Yeah. Mm.
You can start your session, the last session. So we
Okay,
will
okay.
wind up by 1.
Okay. So tomorrow I'll start the assembly module and the service module. Okay, so it's lot. I think it's a very fast one. Okay, so I won't be able to touch all the topic, but I still try to complete most of it.
Sure, sure, sure. Thanks a lot.
Okay.
Thanks a lot, Rajyoti.
Okay, okay. Uh, so can you submit the participant list?
Yes, yes. We have asked for the details that was actually asked by Saha sir. So we
Okay.
are the participants have already filled up. We will be soon mailing the details of the participants along with the feedback.
Okay, okay.
So,
So,
sir, about the attendance, I have sent yesterday, sir.
okay,
My
I have received. Yeah, I've got
yes.
it. Okay, then. So tomorrow at 11:15 a.m. Right.
Yeah, 11:15. Right, right. 11:15.
Okay, okay then. Okay, so that's it for today. And
Okay. Thank you. Thanks a lot. Thanks a lot. So with this, we come to the end of this session. And I request all the participants to kindly join us back again tomorrow for the last day of this EDP program. So till then, thank you all. And
Thank you, sir.
do fill up the sheets that was circulated in the group. And I am circulating few feedback forms also. The links will be shared in the group. You do please fill up those because if you do not fill it up, we won't be able to provide you with the certificates. So please, and also send your passport size photograph. Those who have already mailed, I've received few, so they need not have to worry. Those who have not, please ask your friends to mail the passport size photograph at the earliest, and also fill up the feedback and the Excel sheet, the details that are required. Okay.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Thank you. Thank you all.